This video discusses the various solving methods available in Evolver. If you haven't already done so, you should view the Evolver introduction video in the guided tour series first. The example it illustrates uses the most common solving method, the recipe method. The recipe solving method treats each variable as an ingredient in a recipe, and it tries to find the best mix by changing each variable's value independently. However, there are several other solving methods, each designed for a particular type of optimization model, and examples of them, drawn from the Evolver example files, are illustrated here. This video won't actually show the optimization and final results. Its purpose is only to illustrate the types of solving methods available and how to set them up. You can perform the actual optimization in the Evolver example files. The order method. The order method is probably the second most popular solving method, behind the recipe method. It is used in models where the goal is to find the best permutation or ordering of a set of tasks. An example is shown here, where the goal is to find the assignment of tasks to workers that yields the maximum total proficiency score. To specify the model definition, you select the task indexes in column C as the adjustable cells. You click the Group button, then Edit, and you specify Order as the solving method. Here are the different options. An Evolver model can actually have several groups of adjustable cells, each with its own solving method, but all of the examples illustrated here have a single group. Once you have a set of adjustable cells and you want to change its solving method, you select Edit from the Group command. If you want to identify a new set of adjustable cells with a different solving method, you select New from the Group command. The project method. The project solving method is very similar to the order solving method, except that certain items or tasks must precede others. The project solving method can be used in project management to rearrange the order in which tasks are carried out, ensuring that the order will always meet the precedence constraints. It can also be used in other contexts, such as the example shown here. This model is a variation of the classical traveling salesperson model, where a salesperson must start in one town, end in another town, and visit each town exactly once. There are precedence constraints on the route. For example, towns 23 and 7 must be visited before town 3. The objective is to minimize the total distance traveled. As in the order solving method, the goal is to find a permutation of the town IDs, those in column G. However, only permutations that satisfy the precedence constraints are allowed. For example, in the solution shown, town 35 is visited first, town 29 is visited second, and so on. So because of precedence constraints, town 3 will have to be farther down the list than either town 23 or 7. This is exactly what the project solving method ensures. You can see that this solution isn't allowed because, for example, town 7 is visited before town 13. And it should be the other way around. You choose the adjustable cells and solving method exactly as in the previous order example, but now you indicate the preceding tasks range when you specify the adjustable cell settings. It's using the project method. The preceding tasks range is the range that holds the precedence constraints. And the changing cells are in column G, the order in which the towns are visited. The budget method. The budget solving method is useful when the adjustable cells, or some subset of them, must sum to a fixed number, such as 100%. In such cases, the recipe solving method could be used with a constraint on the sum, but the budget solving method eliminates the need for this constraint. It first finds the sum for the original values of the adjustable cells, and it maintains this sum throughout the optimization. The model shown here is a financial portfolio model. The details can be found in the portfolio mix example file, but the important aspect for now is that the adjustable cells, the weights for the person's portfolio in column C, must sum to 100%, as they do in this initial solution. Therefore, these adjustable cells are specified to be between 0 and 1, and the budget solving method will ensure that they will always sum to 1, that is, to 100%. The grouping method. The grouping solving method is a specialized solving method for cases where you want to find an optimal grouping of items. In the model shown here, the goal is to assign each of 80 securities to one of 5 groups so that the groups are as even as possible. Specifically, the total future value of each group is calculated in column G, and the objective is to minimize the standard deviation of these totals. This is a perfect candidate for the grouping solving method. The model definition is shown here. Each adjustable cell in column D indicates which group the security has been assigned to. Note that Evolver determines the possible groups, in this case 1 to 5, from the distinct values in the adjustable cell range, 1, 2, 3, 4, 5. Alternatively, you can specify the range of group IDs as shown here. The schedule method. The schedule solving method is another very specialized but also very powerful solving method. It can be used to find the optimal scheduling of events when there are constraints on which events must occur with other events, that is at the same time, before other events, and others. The model shown here is an example, and you can learn more about it in the Scheduling Classes example file. Each adjustable cell in column E indicates which time slot to assign to each class, and the objective is to minimize a penalty function, a combination of the number of excess classes that can't fit in the available rooms and excess students that can't be accommodated in the classrooms. The constraints are spelled out in the constraint table. The 3 chemistry classes must meet at time slot 1. The 3 biology classes can't be at the same time slots as the 3 corresponding chemistry classes. And the 3 history classes must be at the same time slots as the corresponding sociology classes. Here is how this model is set up. It's the schedule method with changing cells in column E. And then this dialog box indicates the schedule method. It indicates that there are 6 time blocks, and the constraints are this range right here, that is, in the constraint table. Again, you will probably use the default recipe solving method for the majority of your Evolver models, but the solving methods discussed here provide a tremendous amount of flexibility on the types of models you can optimize.